Hi everyone. Today we're going to study Rolle's theorem. Let f of x be a real valued function defined in a closed interval from a to b, such that in here there are three conditions. The first condition is f of x is continuous in the closed interval a to b. Second, f of x is differentiable in the open interval from a to b. Third, f of a equals f of b. If these three conditions are satisfied, then there exists at least one point C in the open interval a to b, such that f prime of C equals 0. For illustration, look at this graph. This is our f of x. The closed interval is from a to b. We can see that the graph is continuous from point A to point B. And since it is continuous, it is also differentiable in the open interval from A to B. Assuming that f of A equals f of B, then there is at least one point C. The point is here, and it is represented in the graph by the point P. And at point P, we have a horizontal tangent. Let us see example 1. Verify Rolle's theorem for the function f of x equals x squared minus 8x plus 12 on the closed interval from 2 to 6. For our solution, we take note that the three conditions must be satisfied. The first condition is f of x is continuous in the closed interval from 2 to 6. Observing our function here, it is a quadratic function and be represented by a parabola. We know that this graph is continuous, and it is also continuous in the closed interval from 2 to 6. Second condition, f of x is differentiable in the open interval from 2 to 6. It means if we take the derivative of the function, we will get 2x minus 8. And this function here is defined in the open interval from 2 to 6. Third condition, f of 2 equals f of 6. Take note that in our interval here, the first number is a, the second number is b. So our f of 2 is equal to f of 6 must be verified first. Let's begin with f of 2. So this is equal to the x squared becomes 2 squared minus 8x becomes 8 times 2, then plus 12. The 2 squared is 4 minus 8 times 2 is 16 plus 12. If we simplify this, this is equal now to 0. Next is the f of 6. This is equal to 6 squared minus 8 times 6 plus 12. 6 squared is 36 minus 8 times 6 is 48 plus 12. To simplify, the final answer here is 0. We are able to show that f of 2 is equal to f of 6. Both are equal to 0. So the third condition is satisfied. Now, we will look for the value of C. Our step 1 is to find derivative. So f prime of x is equal to 2x minus 8. Step 2, evaluate f prime of C. It means we will substitute the value C to every x that we see on the right side. So f prime of C equals 2c minus 8. Step 3, we set f prime of C equals 0. Then solve for C. So we have now 0 equals 2c minus 8. This negative 8 we will transpose to the left. The negative 8 becomes positive 8 equals 2c. Solving for C, let us divide this equation by the coefficient of C, which is 2. So we have now 8 over 2 equals C. So the value of C equals 4. Take note that this number 4 is inside the open interval from 2 to 6. Showing the graph of our function here, the x squared minus 8x plus 12, we have a parabola. Our closed interval is from 2 to 6. And when x is equal to 4, and that is the c, the derivative of our graph is equal to 0. And then we can say that we have a horizontal tangent at that point. So we say that the Rolle's theorem here is verified. This is our final answer. Verify Rolle's theorem for the function f of x equals sine x on the closed interval from 0 to 2 pi. For our solution, let us confirm the three conditions. Condition 1, f of x is continuous in the closed interval from 0 to 2 pi. We know the graph of sine x. It is continuous. The more that it is continuous in the closed interval from 0 to 2 pi. Second condition, f of x is differentiable in the open interval from 0 to 2 pi, which means if we take the derivative of the function, we have now f prime of x equals cosine x. The cosine x here is defined in the open interval from 0 to 2 pi. Third condition, f of 0 is equal to f of 2 pi. And this third condition we need to verify. Starting from f of 0, we have now sine 0, and the value here becomes 0. Next, for the f of 2 pi, we have now sine 2 pi. And this is equal to 0 also. We are able to show here that our f of 0 is equal to f of 2 pi. Now, the three conditions are satisfied. Let us now find the value of c. Step 1 is to find the derivative. F prime of x is equal to the derivative of sine x is cosine x. Step 2 is evaluate f prime of c. We will change all the x that we see on the right side into c. So we have f prime of c equals cosine c. Step 3, set f prime of c equals 0 and solve for c. So we have here 0 equals cosine c. Looking for the value of c, we will have cosine inverse of 0. Let us remember that the cosine inverse of 0 will have two answers within the interval. So we have pi over 2 and 3 pi over 2. Let us show now the graph of sine x. This is our graph. Our closed interval from 0 up to 2 pi. We can see here that when x is equal to pi over 2 and 3 pi over 2, the derivative of the function becomes 0. And at these points, we have two horizontal tangents. So we say now that the Rolle's theorem is verified. This is our final answer. Today we're going to study mean value theorem. Let f of x be a real valued function defined in the closed interval from a to b, such that these two conditions are satisfied. The first condition is f of x is continuous in the closed interval from a to b. Second condition, f of x is differentiable in the open interval from a to b. Then, there exists at least one point C in the open interval AB, such that we have this equation: f of b minus f of a all over b minus a equals f prime of c. Example 1. Verify mean value theorem, or MVT, over the function f of x equals x cubed minus 6x in the closed interval from 1 to 3. For our solution, we know that two conditions must be satisfied. The first condition here, f of x is continuous in the closed interval from 1 to 3. We can see here that our function is a polynomial function, and we know that polynomial function is continuous. So we conclude that this f of x is continuous in the closed interval from 1 to 3. Second condition, f of x is differentiable in the open interval from 1 to 3. It means if we take the derivative of this function, we have now f prime of x equals 3x squared minus 6. We can see here that our function is a polynomial function. Also, the derivative is another polynomial function. And we say that polynomial function is continuous. And this derivative here is defined in the open interval from 1 to 3. So we say that f of x is differentiable in the open interval from 1 to 3. Then, there exists at least one point C in the open interval from 1 to 3, such that f of 3 minus f of 1 all over 3 minus 1 is equal to f prime of c. For this numerator f of 3 minus f of 1, we're going to evaluate our function with respect to 3 and 1 respectively. Evaluating now, we have this f of 3 becomes 3 cubed minus 6 times 3 minus the f of 1. Our f of 1 now is 1 cubed minus 6 times 1 all over the 3 minus 1 is 2 is equal to the right side is f prime of c. We will take the derivative of this function and we will substitute the value c for every x on the right side. So derivative here is 3x squared. So we write here 3c squared minus the derivative of 6x is 6. So we copy the 6 here. Simplifying further, our numerator becomes the 3 cubed is 27 minus 6 times 3 is 18 minus 1 cubed is 1 minus 6 times 1 is 6 all over 2. There is no change in the right side. On the next step, the 27 minus 18 becomes 9 minus 1 minus 6 is negative 5 all over 2. This minus and minus becomes plus. So 9 plus 5 is 14 all over 2. The quotient here becomes 7. Let us transpose the negative 6 to the left. The negative becomes positive 6. 7 plus 6 is now 13. Let us isolate c squared by dividing this equation by 3. So we have c squared and on the left side 13 over 3. Let us take the square root of this equation. We will have now the value of c to be plus or minus the square root of the fraction 13 over 3. When we simplify this into decimal, we will get the value plus or minus 2.08167. Considering the open interval from 1 to 3, only the positive value of c is accepted. So our final answer is c equals the positive 2.08167. Then we can say that the mean value theorem is verified. This is our final answer. Example 2. Verify mean value theorem MVT over the function f of x equals 8x minus x squared in the closed interval from 0 to 8. For our solution, the two conditions must be satisfied. First one, f of x is continuous in the closed interval from 0 to 8. We observe that our function is a polynomial function, and we know that polynomial function is continuous. So we say that f of x is continuous in the closed interval 0 to 8. Second condition, f of x is differentiable in the open interval from 0 to 8. If we take the derivative of our function here, we can write f prime of x equals 8 minus 2x. We can see that our derivative here is another polynomial function. And we know that polynomial function is continuous. And this function is defined in the open interval from 0 to 8. So we can conclude that f of x is differentiable in the open interval from 0 to 8. Then there exists at least one point C in the open interval from 0 to 8 such that f of 8 minus f of 0 all over 8 minus 0 is equal to f prime of c. Let us evaluate our function here with respect to 8 and 0. So the f of 8 is 8 times 8 minus 8 squared. Then minus the f of 0 is now 8 times 0 minus 0 squared. All over the 8 minus 0 is 8 is equal to the right side is the derivative of this function evaluated at c. So derivative of 8x is 8 minus the derivative of x squared is 2x. But we will write here 2c. Let us now simplify further the left side. In our numerator, the 8 times 8 is 64 minus 8 squared is also 64. Minus 8 times 0 is 0 minus 0 squared is 0 all over 8. There is no change on the right side. We can see in our numerator that this is simplified into 0 all over 8 is equal to our right side is just the same. 0 over 8 is simply 0, and let us now solve for c. This negative 2c we will transpose to the left. The negative 2c becomes positive 2c, and this is equal to 8. To get the value of c, divide both sides by the number 2, so we will have c equals 8 over 2, and this is now equal to 4. Take note that the number 4 is in the open interval from 0 to 8. Now we can say that the mean value theorem is verified for this function. This is our final answer. Today, we're going to study physical interpretation of mean value theorem. If the position of a moving particle is given by this function s equals f of t, at the closed interval of t from a to b, then at some point of time t sub 1, take note that this t sub 1 is inside the closed interval from a to b. The average velocity is equal to the instantaneous velocity, that is f of b minus f of a all over b minus a is equal to f prime of t sub 1. Take note that the left side here is the formula of average velocity, while the right side is the formula for instantaneous velocity when t is equal to t sub 1. Example 1. If s is equal to negative t cubed plus 3t squared minus 3t in the closed interval for t from 0 to 3, gives the position of a moving particle, find at what time the average velocity is equal to instantaneous velocity, s in meters and t in seconds. For our solution, let us write our formula for the mean value theorem. Now, let us evaluate separately the left side and the right side. Starting from the left side, the values for a and b are required. That our a and b are the endpoints of the closed interval. The 3 here is the b, and 0 is the a. So for the left side, we will write now f of 3 minus f of 0 all over 3 minus 0. In our numerator, we will evaluate our function here with respect to 3 and 0 respectively. So the f of 3 now becomes negative 3 cubed plus 3 times 3 square minus 3 times 3 minus the f of 0. So we write here negative of 0 cubed plus 3 times 0 square minus 3 times 0 all over the 3 minus 0 is simply 3. Simplifying further, this negative 3 cubed now becomes negative 27 plus 3 times 3 square is 27 minus 3 times 3 is 9. Then minus this whole group here is equal to 0. So we write here 0 all over 3. We can see here that our numerator is now equal to negative 9 all over the denominator 3. And the quotient will give us negative 3. This is the value for our left side. Next, the right side, f prime of t sub 1. We're going to take the derivative of our function and evaluate it at t sub 1. The derivative of this negative t cube is negative 3t squared. But we will write here negative 3t sub 1 squared. The derivative of 3t squared is 6t. But we will write here 6t sub 1 minus the derivative of 3t is 3. So this is our value for the right side. Let us now substitute the values of the left side and the right side respectively in this formula. So we have this negative 3 is equal to negative 3t sub 1 squared plus 6t sub 1 minus 3. Let us now solve for t sub 1. We can see here that the negative 3 is common in each side of the equation. So we can cancel those negative 3's. So we have now 0 is equal to negative 3t sub 1 squared plus 6t sub 1. In here, let us factor out a common factor. And that common factor is the negative 3t sub 1. We have now this negative 3t sub 1 times the quantity t sub 1 minus 2. We're going to equate each factor into 0. So we have this negative 3t sub 1 equals 0, and this t sub 1 minus 2 equals 0. For our first equation here, let us solve for t sub 1. Let us divide this equation by negative 3. So t sub 1 is equal to 0 over negative 3. Simply, this is equal to 0. In our next equation, t sub 1 minus 2 equals 0. Let us transpose this negative 2 to the right side, so the sign will be changed. So t sub 1 is equal to 2. We can see here that we have two values of t sub 1. Or we can say that we can change this t sub 1 into t sub 2. So the 0 and the 2 here means 0 second and 2 seconds. Take note that the answers here are inside the closed interval from 0 to 3. So these are our answers here. Example 2. Find the time at which the average velocity is equal to instantaneous velocity for s equals 6t minus t squared in the closed interval for t from 0 to 6. For our solution, let us write the formula for the mean value theorem. Then let us evaluate separately, starting from the left side. So we write f of 6 minus f of 0 all over 6 minus 0. Let us now evaluate our function here with respect to 6 and 0 respectively. So the f of 6 equals 6 times 6 minus 6 squared. Then we'll copy the minus sign. Then f of 0 is now 6 times 0 minus 0 squared. All over, the 6 minus 0 is simply 6. Simplifying our numerator, 6 times 6 is 36, minus 6 squared is also 36, minus 6 times 0 is 0, minus 0 squared is 0. 36 minus 36 is 0, minus 0. So in the numerator, we can simply write 0 all over the denominator 6. And the quotient here will give 0. This is the value of our left side. Now for the right side, f prime of t sub 1. Let us take the derivative of this function and evaluate it at t sub 1. So our f prime of t sub 1 is equal to the derivative of 6t is simply 6 minus the derivative of t squared is 2t. But we will write here 2t sub 1. We have now the values of the left side and the right side. Let us substitute the values respectively. So the left side is 0, and this is equal to the right side, which is 6 minus 2t sub 1. Let us solve for the t sub 1. Let us transpose the negative 2t sub 1 to the left side. The negative sign becomes positive 2t sub 1 equals 6. Let us divide this equation by the coefficient of t sub 1, which is 2. So t sub 1 is equal to 6 over 2, and the quotient here gives us the value 3. This 3 here is with respect to time. Again, we write the unit seconds. 3 seconds. Take note that our answer here is inside the closed interval of t from 0 to 6. This is our final answer. I hope you learned something from this video. See you again next time.